today, as we put away the great test microphone and get out the Uniden test mic, there should be the clue. So we did the Fidelity 1000 yesterday, and although it was a difficult and time-consuming and potentially expensive repair, the radio worked very well. Well, it did here. So this is supposed to be something like a Uniden 100. And this is from the same person, but there's a rider to this, which I'll tell you when I open it. You're all suspenseful. Whoops! Oh, it's got its side bobbles. Never were there such days. Something for us to lose. So he bought this off a friend who was strapped for cash. But he said to me, you can either keep it, or you can repair it and he'll pay for the repair, and then he'll just simply sell it because he doesn't want it. So I think we'll keep it, and I've got a little thing in mind. If the phase lock loop chip works in this, then I won't charge him for the phase lock loop chip I put in the Fidelity 1000 yesterday. So there we go. That's the deal. I haven't told him that yet. So let's get this. I was going to say let's get this connected up. No, we can't, can we? Because we've got those capacitors to change. Because it's a Uniden, and we need to change those 4 capacitors before daring to power it up. Unless, of course, they're being changed. I notice it's only got 2 screws for the speaker, so I wonder what's happened there. At least it's got all the original shiny silver screws for the case, which are usually missing and replaced with slotted countersunk wood screws, or worse. If it could be worse. I had a business radio once in with the case pop riveted on. So I've got the soldering iron ready. Oh, it's still got the rear screws. They've nearly always lost those. Ah! Right. So what's this? Some kind of Roger Silly, I expect. I don't know, they get a quality radio and then they do this to it. I feel the same with church organs, you know. You go to a church and you've just either installed a rebuilt organ for, you know, like 35,000 quid, and you go and tune it the very first time, and they put drawing pins in the console so they can put the piece of paper with the hymn numbers on. You say, would you actually do that to your piano at home? Absolutely disgraceful. So that's a Roger 5-tone to go into the vertical filing cabinet. So, change his glasses so we can see what we're up against. So that 220 microfarad is the most problematic one. We've got the other 220 which can play up, and there's the two 470s, one of which is in the audio amplifier. Some of these can play up, but I would only change them as necessary, usually. At least it hasn't had anything illegal done to it. Good. Right, so I'll get those unsoldered, and I'll join you when I put them in. Right, so there we are. I've hopefully taken out the silly wiring and restored things back as they were to the mic socket. Very thick power lead. I think it's once belonged to a 25-watt marine radio, looking at the thickness of that. I don't like this black wire which goes to this PA switch. I wonder if they've made this thing switchable, that Roger bleep, and taken out of operation the public address feature, which I would find disappointing because it's more work to restore back. Can't tell at this stage. Right, we'll switch on and off switch is loose, so we'll have to have the front off and tighten that up. And let's turn the squelch down, which is also loose. Well, that's a good sign. Except that's so loose it's not working. Right, shall I get a piece of paper and we'll write down the parameters. Oh, it's the percentage of viewers of our other channel, Pipe Organ Hymns G0OJF. Right, switch picture and picture on. And of course we've done these four capacitors, 470 microfarads, 470 microfarads, 220 microfarads, 220 microfarads. I'll tell you what, let's test what we've took out. You never know, they might even work, but they're not going back anywhere. 513 instead of 470. Usually when they go high, it's indicating that they're coming to the end of their life. That's spot on. That's slightly high. That's slightly high. But I can assure you that if we left them in, they'd be knackered by next week. Right, transmit. Are we on low power? We are. 4.2 watts. Transmitted audio, wallow. There isn't any, so I must have got the wiring wrong. Wallow, I'll have to look into that. So receive. Or is it because it routes through this? Voila. Yeah, the PA switch is not doing anything. Sad when that happens, it takes some putting back. Right, deviation we can't do. Frequency, well, you can't adjust these sets. That's fine. 2779118. It should be 79125, so it's virtually spot on. Receive. That's where these get let down in the sensitivity department, and this is probably why people say they get less bleed over than other sets, because they're less sensitive. Right, we'll put the cyanide meter on, and I'll switch picture-in-picture to the cyanide meter. So we'll adjust that till we get 12 dB. Let's put the volume up a bit if I can. It's a bit dodgy, as you heard. It's exactly 1 microvolt for 12 dB cyanide. We can go on a different scale, see what that says on a different scale. It says 1.05 microvolts. So yeah, 1 microvolt. 1 microvolt for 12 dB cyanide, so that's fine. So we'll start by going through the transmitter. I'll use the realistic service manual because it's the same as the TRC 2001. Oh, what's the specification for sensitivity? Oh, they do it to 10 dB. We'll take another reading. There's 10 dB. 0.88 microvolts for 10 dB. So what they say here is the nominal spec's 0.5 microvolts, the limit is 1. So it's 0.88, so it's already well within. The first thing we do is put the radio on channel 40. Turn the volume down, get the multimeter out. I'll go back to that, and we are looking for 3.5 volts on transmit. I can never remember whether these are a floating chassis or whether they are negative. Helps with the meters on. Floating. Sorry, it's negative earth. Good. Just put the other glasses on. So we want, on test point 1, we want 3.5 volts. And test point 1 is that resistor just there. So test point 1 is resistor 52. It's the only one which doesn't have paint on its standing up leg. So 3.5 volts plus or minus 0.1 on channel 40, and that's not good enough. So we need to change. We need to adjust. Oh, sorry, we're not on transmit. To Wally. 4.16. Well, it's still the same results. It's not good enough. L17. And then on receive, yeah, it's going over to test point 3 for maximum on an oscilloscope. Now I'm not going to do that at this stage. We'll do L18 later, because you end up adjusting it at this point with test point 3, which is resistor 6. It says test point 3 just there. That's resistor 6. So you do that with an oscilloscope, but then you still got to readjust it when you come to do the receive tune-up. So I think we may as well just leave it till we do that. If the radio was manufactured brand new or been really, really fiddled with, then we would do it at this stage. But the radio's already receiving, so it's only going to be a marginal amount. So we'll leave that for now. So my transmit tune-up, we'll go over the page. We go to channel 20. Centre of the band, in other words. They do receiver first, which we do it the other way around. So it starts with L16. So it's 16, 15, 14, 13, 12 and 10. So let's go for it. So we're doing 4.2 watts at the moment. We'll set that correctly at the end. So check it, we're on maximum. Yep, that is peak. Because even though it's doing overpower, it may not be at correct peak. We'll just change tools. You can see me spending half an hour on a tune-up on this, and then 90 minutes putting the PA function back together. So now we've dropped it to 4. So that's the power setting point. So if you're over like we were there, that's the thing, and it's tuning it down for the correct. Unless of course it was dangling out of the top, but it's turning down, and that's so it was clockwise. So that's now spot on. We'll skip the deviation because we're going to have to find out what's happened to the modification I thought I'd remove but failed to. So we do 0.4 watts, so we'll switch it to low power. Let's see what we've got. Well, we've actually got 0.9 of a watt. So that's no good, we need to adjust that. Preset there. Ah, it's dirty. Waggle that around about, having used the service all switch cleaner. There we go, 400 milliwatts. And then switch to the highest power range, which is 30 watts on this. And there we have 4 watts. So good. So we need to make sure the meter is reading something like where it should do. And it says here that with variable resistor 3, which is the one at the back, adjust in transmit till the needle is in the blank zone between green and red. So it should actually be spot on that blank zone. So that is 4 watts into a dummy load. Of course, when we put it on there, it might read nothing, it might read jumping across the scale, means nothing. It's all relative to SWR. So that's all we can do at present, because I said the deviation is a problem. We'll carry on with the set, and we'll now move straight on to receive if we can actually persuade the volume control to actually work. Take away the meter. We'll start with the detector. Did they tell you to? No, they don't. They tell you to do that later. So we're going to 100 microvolts signal, which is equivalent to S9, and we'll have a look at that on the oscilloscope, which I'll switch on and turn the bench light off so we can actually see the screen. Can we advance it? Yes, we can. And it sounded like, can we fix it with Builder Bob? Bob the Builder. the detector is the coil there. Maximum recovered audio. It was absolutely spot on as it was. So we've turned the oscilloscope off, we're done with that. We'll go to the synad meter and we will now set to attenuate it to about 4 dB and turn the volume down a bit. And then we'll run through the front end. No improvement there. Tiny improvement there. I'll just turn my signal generator back down again. Watch transmit on these. Spot on. Look at these IF ones. The biggest signal on for these. Very slightly out on that one. Not out on that one. So that's it. We're done. Let's get the new reading for 12 dB synad. I doubt if it's even different. Except that I've knocked the... It's the squelch control which is the one playing up. There's our 12 dB. You know, it's 0.95 microvolts. Let's go on the other scale. Yeah, it's 1 microvolt, so it's just the same. I'm not going to say it's better. It's so marginal. And let's look at it for 10 dB. .85. It was 0.88. So, you know, that's it. It was already spot on. Tiniest thing. You might get an extra foot range on this set now. We'll go to an S9 signal once again. It's 100 microvolts, and we will look at where the S meter is. That should be S9. And look at that. It's spot on. So just to demonstrate, it is that preset there. No, it's not. It's that preset meter there, which says SM. We'll just put it in the centre of that red dot there, which is supposed to be 9. And then we'll look at the squelch if we can, because it's a bit dodgy. So we'll turn the squelch to full. So at 100 microvolts I want the squelch to open, and it doesn't. So we need to just back that off a bit with the squelch preset. And it's the one that says SQ. There we go. So turn the signal generator down. So the squelch has come in, turn it up to 100 microvolts, and it now opens up, which is exactly where we want it. See if we can set threshold. We may not be able to with it being a dodgy control, so we'll just turn the set down till it hisses, if we ever get it to. Set threshold if we can. I think that's threshold. I may have to do this test again when I fix that. Oh, I'll start again. Try it there. No, I need to fix that first. So that's all we've got to do. Find out where the deviation is disappearing to, and then start about rebuilding the public address feature. So I'll pause the video and get on with some work. Whilst I've got this radio in bits to do this, I found some of the wiring. I'll just have to take another set apart and find out what goes where. I've taken this, pretty easy to take that off because the glue had just about failed. The escutcheon there off the front, that then enables you to get, well, I just use the long nose pliers to get around the nuts and tighten those up. So that's the end of that problem. And then we'll glue that back with a impact adhesive such as Bostik, which we should have got here on this bench. But before I do that, we'll just clean some of the crud off it. The next day, Glenn kindly took a photo taking the lid off his set, and there we have how it should be. Oh look, he's got a repaired crack across that printed circuit. The best I could have extracted from one of my videos was that, and it just needs the wires pulling out of the bunch to be able to see. So that can be screwed up, and that can go on the floor with everything else. So I've put that photo on file now. So let's remove that. So here we go. White. Well, this is fun to get them under there, isn't it? Huh. I think we'll take that tie wrap off. Blue. Orange. Do we have an orange? We'll come back to that. Oh, is it brown? Yeah, it's brown, isn't it? Clean a bit of that surplus solder off. Don't really want to cut it off and shorten it any further. Just wonder if we can pull that through a bit of a quicker route. to get some of the solder off that one as well. Black. That looks like it's the one that goes in that lower hole. I'm just going to check that it fits through the hole. It does. I'll try and put it in with pliers then. And that leaves us with red. Oh, red's there. That red one's in the wrong place. Just check again that goes through the hole. I'll do that from this side. Yes, it does. Let's see whether I can pull a bit more out. In other words, push the sheath back. Yeah, done that. There we are. And finally, we should have got a white one somewhere. Oh, there's always one, isn't there? Oh, it's already in. The grey wire is there. So I've kind of unsoldered it, but it's actually still there. So they hadn't got rid of that one. So we'll just double check. White, blue, brown, black down there, red, grey, orange and yellow. Be careful never to over tighten these screws. It's only keeping the face plate on. You see so many of these fronts on all makes of radios cracked because they've been over tightened. So I'll get a cable tie back in there later on, and hopefully we're going to have some audio, because don't think we had any audio, did we? So hopefully that will have fixed the audio problem. I'll just put one case screw in so that the case doesn't go wandering and shorting out the bottom. Right, we'll get it all connected up tell you what, we'll put that. Yeah, we'll put that in there. We'll put the speaker mounted on the wall into the PA socket. Excellent. Switch the power on. 13.8 volts, 1.6 amps. So we are lit up. Where did I put the mic? So going to transmit. I'll put picture in picture on. Going to transmit. See if we've got audio. Wallow. Still got no audio. So have we got audio on PA now? Testing 1 2. Testing 1 2. Testing 1 2. No audio on PA either. So something's happened where I wonder if they've cut a track on the printed circuit board so the audio could get routed through. I'll have a look at that behind the scenes. So I think we've actually got a fault. So I know when Dave tested this, I think he said the deviation was all over, far too high, and whether or not it's been killed by the Roger bleep or whether it's been it's just another capacitor that's failed. So if we look at the audio processing on these, we've got the microphone. I'm looking at the realistic manual for the 2000, but it's the same beast. So we've got it coming in, audio in on pin 3. So if I key up, I've got it on low power, I've got the monitor receiver on rather than use PA. If I touch pin 3, actually we've got a lot of audio there, haven't we? Yes, there's nothing amiss there. So, what could be amiss? So it can't be being dragged down. So we should be. We have resistor 83 4.7k, and then it's straight to the mic connector. So it looks like 83. So can we spot resistor 83? Yes, we can. The resistor 83 is there. So if I touch it there, yeah. If I touch it on the underside, let's just find it on the other side. So we've either got a short circuit capacitor, which is highly unlikely because they are ceramic. Or we've got an open circuit resistor, which is also highly unlikely. Anyway, I'll pause the video and we'll take the resistor out. Was that a raised potential? So that was what was happening, was being shunted to at the mic socket. Because you've got the decoupling capacitors at the mic socket. So you've kind of got a floating part of the ground there, and it wasn't floating, so it was shorting it out. So that, yeah, Dave said it was over deviating. So in transit, that whisker of wires happened. Because the only wire I've touched is the orange one, which of course had to be restored to its correct position. I haven't touched the red one, so there we are. We're done. So bit of a thing to find out, and a lot of a thing to get somebody to email me a photo. So thanks to Glenn again for that. We'll put this lid on with the set on live, just being over the top. Put the meter on continuity. It's not that one. It's that one. So with them both being grey wires, so it's the one towards the back you've got the grey wire towards the back of the set, nearer the power connector, and of course you've got the grey wire further towards the front, so the back one is the negative. No, we're on 3/8. 19 Roger. Of course they won't be able to hear us because we're not naughty over there. There we go. So that is going to. I'll just put the escutcheon back on, and that'll be then ready for an on-the-air test with Mr. Chippy. Don't think we can fit that in today, but it will happen in the next few days. So there we are. Thanks for watching. Quite an extensive job to the Uniden 100, and thank you for Dave for passing it on to me. Cheers.